Hello to everyone. My name is Raul Sosa, and this is my milestone 2 presentation for summer 2024 in the course of educational technology. My topic for this research is quantum computing technology. Basically, I'm going to be talking to you about recommended teaching approaches for hard to learn concepts and topics. My research is mainly focused on some areas that are important to highlight because of the delay that we're having on the progress of these new emerging technology in some educational institutions. Basically, it is important to go back to this technology to understand why this is very revolutionary and why we have to think about it as a very relevant subject. If we think about every time we have created a new code of data processing of information, there have been some significant disruptions in the world. For example, if we think about the numeric code that was invented in Sumerians in 3400 BC, it was very important for humans to understand that code at that time. Later, the DNA code was not really invented, but it was found by Frederick Manchester in 1860, which was a very important discovery because after that, we could understand a little bit better the different living things in the world. After that, we can think of digital binary code, which is basically related to John Anosov in 1940. About 84 years ago, it was invented. And it is a code that only uses zeros and ones as the basic numeric numbers or states that the code mainly work on. Now, after that, the quantum multi-state code was invented. Let's say that around 1988, about 20 years ago, this multi-state code was invented and it was started to be used in new quantum computers. Now, it is important to understand that this new code is in the process of being implemented in the technology world, and we are in that process. Now, it is important also to have a big picture of what is going on in the last decades. For example, in 2023, we are thinking about the 128 bits in the computer process designs. But before that, you can see all the phases that have to be considered before having the current 64 computers that we are having right now in the classical digital environment. It is important because, as you can see here, the maximum data processing of 128 bits would be amazing now. There have been some intentions to create processors of 128 bits, but it is not feasible because it doesn't make sense. Now, in the world of quantum computing, it is important to understand that right now the biggest computer power is around 433 qubits, which is the most powerful computer from IBM right now that is working and giving cloud services to everyone. And they are now thinking about providing a 1,000 qubits computer processor, which is going to be very significant to the future of these data processing in quantum realm. It is also important that from the classical digital binary perspective, there can be some limitations to create new processors because we have reached the minimum of 1.4 nanometers, and that implies that probably the manufacturers of processors are not going to be able to create more, let's say, smaller processor designs because we are reaching the physical limit of the processor creations. Now, right now, we can think of a hybrid computer design that is being providing cloud services. In this design that we're using right now, you can see that the hardware design is in the physical layer down there, and the logical layer up there is the one that integrates the quantum integration with the digital classic binary technology integration. And that's why we're being able to understand a little bit the quantum computers right now. This design is very important because that's exactly what we can see right now. And it is highly relevant to the intention to start introducing the students to the new designs and how they work. Now, having these kind of computers in mind, there are some companies that are working right now in different platforms that enable these students to create algorithms and try to interact with the different cloud computers, and they are really doing a great job about it. Now, some other companies like IBM, D-Wave, Google, Intel, Amazon, and all these that you see in this screen are really working very good too to provide different services and progress on the quantum computer realm. Additionally, some universities, as the one that you see here, according to my research so far, they are trying to include in their programs new careers, new degrees that can help the people to start understanding, to start introducing things early stages in university to help a student to understand this technology. And you can see right there that the Georgia Tech is also aware of this situation. Now, what are the additional implications of quantum computing technology? Well, there are some great potential to change the following things when we think about quantum computer. The current silicon processor, for example, these processor chips, the actual processor chips can be replaced by photonic processor chips, and this implies that the electric energy for computers will be replaced at some point in time by light energy. And this is so significant because remember that right now there are so much consumption of electric energy in the world, and this might change even the benefit of protecting the planet because of carbon emissions. Now, the new data processing and communications are going to be exponentially higher than now. And we're going to have at some point in time really unbreakable cryptography and encryption methods. Now, if we think about this technology, which is definitely really relevant, but if we do not use education to get the appropriate progress on this technology, probably is going to take more years than what it should. Now, the issues on current quantum computer technology education are the next ones. Actual education is only application-oriented based courses. In other words, they use quantum algorithms to solve problems only. The education approach is not still considering the full migration to a new multi-state code rather than current digital binary code. Actually, education is not a new discipline nor a full career that could be followed by a student as a new professional. And additionally, not every high school, not every college, not every university right now have courses or degrees in quantum computer technology or quantum technology by itself. So it's kind of, we know the technology is there. We know that it's very good. We know that it has all the potential, but we still have not taken these steps to help the student to get into this knowledge and get benefit of it. Now, there are some educational areas that could be improved to move forward faster. Among all aspects that can be considered, the following have been found as critical to accelerate and mitigate the education issues. For example, we can create mini courses, careers, degree programs, and complete passive education in high school courses, colleges, universities. Undergraduate minors, majors, graduate masters, PhD specialization in quantum computer technologies. And also students can consider some topics not easy to grasp since the beginning because they are not used to multi-state parallel background recursive data processing. This is quite so different, and that's why it being not so easy for a student to grasp this new knowledge, and they are staying back on the digital classic binary processing. Now, the focus of this research is to encourage getting closer to a solution. The next step of my research, understanding all this, is that even having in mind that most educational institutions are not in the position to improve all these issues about quantum computing and quantum technology, but for the purpose of this research, the following two specific collaborations will be provided, mainly to start helping on these issues. One of them is proposal of a more complete set of courses or degrees in quantum computer technology for educational institutions to consider them and create their own specific programs. And the other one is a mini course example of key elements of hard to learn concepts and topics at teachable.com platform, which is something that I consider is going to be a very good online virtual education platform that can be used. Now, having all this in mind, we have to understand that the main purpose of my research is if we have quantum technology, if we have quantum computers right now, the concepts are clear. We right now have even photon oriented processors. I mean, processors that uses light instead of electric impulses to work inside a computer processor. If we have all that already available in the world, we should pay attention to that. Why? Because it will definitely change the way we operate, the way we create algorithms, the way we interact with computers in the near future. And finally, I'm going to end up this presentation with a quote from Richard Feynman, a person who understood that the classical nature cannot be simulated by the digital binary code. It cannot be. There should be a quantum mechanical approach to really have a simulation of nature. Whatever you want to simulate, for example, if you want to simulate the way of how the weather behaves, or the way how the proteins behaves, or how we can create different new formulas for chemical new medicines. That is going to be easier with quantum computers, and this is something that is definitely going to revolutionize the information technology arena. I don't want to take more time from you today. On next steps in this presentation, I'm going to show the mini course content on this video at the final deliverables. And also, I'm going to show the last paper and also the final approach of my research during this semester. Thank you so much for to Dr. Debbie Joner, my mentor, Ken, great work, and I've been doing it. I've been really enjoying this course. Have a great day.